Hi everyone, this video is regarding point, line, and plane postulates 5 through 11. It's mainly definitions with examples. So the first thing you need to know before we start is this one. A line perpendicular to a plane. A line is perpendicular to a plane if and only if, so this is like a P, if and only if Q. The line intersects the plane in a point. So and is perpendicular to every line in the plane that intersects at that point. Here are your postulates that are regarding point, line, and plane postulates. So we have an example here, and I have some more that we can go over these without me just reading them. So for the example 1, identify a postulate illustrated by the diagram. So if we have if, this is if, then, if you have 3 points that are non-collinear, then there's a plane there. So there exists a plane. So let's find that postulate, and that would be postulate 8, as it's already written. Through any 3 non-collinear points, there exists exactly one plane. All right, and the next example, it says use the diagram to write examples of postulate 9 and 11. So let's read postulate 9. A plane contains at least 3 non-collinear points. So let's look at the diagram and find the plane. So let's see. We have 2 planes. We have Q and P, or Q and P there. So let's look at P. It doesn't look like we have 3. We need to find 3. So let's look at Q. We have V, Y, and W. So that would satisfy postulate 9. Postulate 11 says if 2 planes intersect, then their intersection is a line. So we have 2 planes here, P and Q. They're intersecting here, and there's the line, and it's called B. So that was postulate 11. Next one. Which postulate allows you to say that an intersection of a line A, so I'll do line A, and we're intersecting in line B, so I'll call this A and this B, is a point. So this intersection is some point. We can call it X. So if you look at postulate 7, it says if 2 lines intersect, then their intersection is exactly 1 point. Write examples of postulates 5 and 6. So postulate 5 says, through any 2 points, so I'll put 2 points somewhere, there exists exactly 1 line. So there it is. Let's call this line, well, what did they do? So line A, and our 2 points would be X and Y. And what does postulate 6 say? A line contains at least 2 points. So postulate 6, we're going to draw a line, and then it contains at least 2 points. So this would be X, Y. At least it could have more. It has infinite points on the line. Let's see, example 3. It's a sketch of diagram showing that RS, so line segment RS, is perpendicular to a line TV. So I'll put mine on this side because I did it on the other side. So this is RS, and this is TV. I'll put a T here and a V here. And it's perpendicular, so that means I have to write this right angle symbol here to show you that it's perpendicular. All right. And then our x is a point. So that point right here is x. Okay? Interpreting a diagram. This little thing here, it means things you cannot assume about this diagram. You cannot assume that all points are coplanar. That, for example, these two angles, or this angle here, let me do it a little better. So this angle here is a linear pair, has a linear pair. So this angle and this angle are linear pairs because they're not marked. And there's no information about the size or measure, because you have to have information about the size. And there's a load of stuff here. Let's look at this last one. AD, where's AD? AD perpendicular to BF. You can't assume that. And the reason you can't assume it because you don't know the measure of this angle. You have to have this little right angle symbol to be able to assume it. So you need everything you need to know. It has to be information about size or measure. All right? Which of the following statements cannot be assumed from the diagram? So how many statements do we have? 1, 2, 3, and 4. There's no right angles marked, so you cannot assume that BD is perpendicular to EC, because there's not that mark right here. All right, and also you cannot assume that EC, where's EC? This line is perpendicular to plane G. So you can't assume that it's perpendicular to this whole plane here because it's not marked. Otherwise, 1 and 2 is fine. E, D, and C are collinear. They're in a straight line here. And the intersection of BD and EC is D, because that's marked, like we did in the previous slide. And finally, it says, in example 3, so we already did this. If the given information indicated that R, X, and X, S are congruent, how would the diagram change? So basically, let me draw it. This is perpendicular. We have T, V, S, and R. And they didn't draw it to look like a midpoint. So for this RX, this is X here, then you would have to mark this as congruent like that. Then that would tell you it's congruent. And then it says in diagram, for example 4, and we already looked at that one, can you assume that BD is the intersection of plane F and plane G? So we're looking at the line BD, so this whole line is at the intersection of this plane F and G. And yes, you can. It doesn't have to do with being marked. You can just see that it's intersecting. Just like you don't have to mark when two lines are intersecting. You can just see that it's intersecting. You can assume that. All right. And that's it. Thank you. Have a nice day. Bye bye.